I'm Anil Kumar. In this series, we are trying to figure out distance between lines, distance between a point and the line, distance between point and planes, and distance between skew lines. Now here, we'll concentrate on two questions which are based on distance between parallel lines. Question number 1 here is, find the distance between the lines 2x minus 3y plus 6 equals to 0 and 2x minus 3y minus 2 equals to 0. You can see that both the normals are equal, right? Therefore, the lines are parallel. So here we have normal n1 is equals to n2. So that means parallel lines. And that is in R2, right? The question number 2 here is, find the distance between the line R 1, 2, 1 plus S 1, 2, 3 and R 1, 0, minus 1 and T 1, 2, 3. So again we see that directions are equal, so we have M1 equals to M2. So again we have parallel lines. The only difference here is that this second case is in R3, right? So we are going to apply the two methods which we learned to find distance between a point and a line in R2 and R3. So this is similar to distance from a point to the line in R2, and that one is in R3, right? So the idea here is that if we have two lines, let's say two parallel lines, let's say these are the two parallel lines, in that case distance between them, that distance could be found by actually picking up a point on the line, right? So if you pick up a point on the line and a general point on the other line, then that becomes a triangle to look into to find the distance, right? So let's solve them one by one. Question number 1, which is based on R2. We are given Cartesian equation. So we'll solve question number 1 first. We are given Cartesian equation in R2, which is 2x minus 3y minus 2 equals to 0. So let's consider this to be the line L2, let us say, right? So let's say this is line L2. The first line is also parallel to this, but what we will do here is we'll find a point on the first line. So let's try to find point on L1, which is 2x minus 3y plus 6 equals to 0. Now we could place y equals to 0 and calculate x. That'll be easy. So let's say y equals to 0. In that case, we can say 2x equals to minus 6 and x is equals to minus 6 over 2, which is minus 3. Therefore, a point P could be defined here as minus 3, 0. So now we have a case where we are trying to find distance from a point minus 3, 0 to a line L2 in Cartesian form. So basically, we'll find distance from the point minus 3, 0 to the line. Now since all these points are same distance away, so that gives you distance between two parallel lines. I hope that makes sense. And the formula, as you remember, is A0, you can say AX0 plus BY0 plus C magnitude divided by A square plus B square plus, yeah, so that is the direction. We are working in R2. So what we get here is 2 placing x as minus 3, we get magnitude of 2 minus 3 minus 3 times 0, since y value is 0, minus 2 magnitude over square root of 2 square plus minus 3 square. So that gives you minus 6 minus 2, which is 8. Let me write down. So we have minus 6 minus 2 over square root of 4 plus 9, which is 13, and the numerator is minus 8. Absolute value makes it positive 8. So we get 8 over square root of 13 as the answer. So for the first one, the answer is 8 over square root 13. Well, you can find decimal value. You could rationalize also and write this. So you could also write this as 8 square root 13 over 13, right? So I hope that is clear. Let's do the second question now, where we'll find the distance from a point to a line in R3. So in question number 2, we are given the two lines which are parallel since their directions are same. So we know M1 is equal to M2, which is 1, 2, 3. We have points on each line already given. Let's say P for us is 1, 2, 1, and Q is 1, 0, minus 1. So PQ will give us another direction. So what is PQ equals to? PQ will be 1 minus 1 is 0. 0 minus 2 is minus 2. Minus 1 is minus 2. So let's find the cross product between PQ and M. Let me write down the formula here. So this distance will be magnitude of cross product of PQ with M over the magnitude of M. So that gives you the normal, right? So that is how you figure it out. So let's find the cross product of PQ and M. So PQ cross M is 0 minus 2 cross M is 1, 2, 3. So we could write this as minus 2, 0, minus 2, and we'll write this as 2, 3, 1, 2. So you need to add these products and take away that, correct? So that is how you are going to do, correct? To find each component. So that gives us the I component as minus 6, minus of minus becomes plus 4. The J component is minus 2, that is 0. And the K component is 0, minus becomes plus 2. Now the magnitude of, let me write PQ cross M will be, this is minus 2, 2. Okay. So the magnitude is square root of 4 plus 4 plus 4, which is we could write this as 4 times 3 or 2 square root 3. Correct? So 12, 2 square root 3. And the magnitude of M is what? Magnitude of M is square root of 1 square plus 2 square plus 3 square, which is 1 plus 4 plus 9, which is square root of 14. Therefore, the distance D is equal to 2 square root 3 divided by square root of 14. Right? So that becomes the exact value. You may have to sometimes write in decimals, round it to some number. You could do this using the calculator. 0.92, let's say 6. So that is how you can actually find distance between parallel lines. So remember one thing, it is similar to finding distance between point and a line, right? So it is similar to find distance between point to the line, right? So I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Thank you and all the best.